Welcome back. This is the presentation for Lesson 3, in which we'll be covering a variety of topics, including strings, booleans, and functions, and perhaps a few other related things along the way. So we're now into the flow where at the beginning of each of the sections, I will call out for you which of the topics we covered in Lesson 2 we'll be dealing with. You may remember those 7 topics and their key colors. So in this section, we'll be talking about syntax, data types, and operators, or covering some new syntax, data types, and operators, I should say. So let's dive in. What are strings? Well, they are a data type that is used to store one or more characters. So we're talking about basically things that are going to be used to record or send messages or information that someone might read or something along those lines. So in the previous lesson, we talked about numbers, and we often do math with numbers. Well, when we want to show numbers or other messages to people, we usually put them in sentences like, your total price is $, followed by the price. So this is where strings come in handy. They are declared using the following syntax. Now, pardon the typographer's quotes. Our presentation software here likes to autocorrect my quotations into typographer's quotes. But we really would be using in the first line single quotes on either side. That's just the key next to the return key on your Mac keyboard without any shift held down, just a normal single quote. And we put one on each side to open and close a string. We can also use double quotes, as you see on the second line in that elvish greeting. And then the third line, we are declaring a variable and assigning to it the string value fill. You can see that fill opens and closes with strings on either side, and then there's a semicolon at the end to terminate that full statement. And of course, we'll also commonly be logging values out to the console, as you can see on that fourth line. Now, we're going to use something called concatenation and the concatenation operator to combine strings with other strings or other variables. So look at what I'm doing in the code below. We create the variable name and assign to it the string fill. Then we log to the console the message that begins with the string hello, space. Notice that that string ends right there. There's an opening quotation before the capital H, and then a closing quotation after the space character that's after the comma. Then the plus sign there is the concatenation operator when we're dealing with strings. Now I know that looks like the same operator as the addition operator, and it is. It's the same symbol on your keyboard. You press the same thing. But JavaScript is going to detect that there are strings on either side, and if there is a string on either side, it will not treat it like an addition operation. It will treat it like a concatenation operation. And that simply means that the value that is stored in the variable name is going to just be tacked right onto the end of the string that comes right before it, the hello, space. So what you'll have is hello, space, and then fill. Notice that then we concatenate another string that begins with a period, space, welcome home. So if you're following, what's going to happen is that simply the plus name plus is going to be pulled out of there, and in its place is going to be inserted the value of the variable name, which is just the string fill. So the final result that will be logged to the console is hello, fill, period. Welcome home. Right, we've got another example on the next line. This time we've made it a little trickier in that the variable we're dealing with is a number. It's the number 5 that's being assigned to the variable age. So, like I said just a moment ago, when you have a string on either side of the addition operator, it is no longer the addition operator, it is the concatenation operator. So the value 5 is converted to a string and dropped in there as the number 5. So the phrase would be, the child is 5 years old, period. On the next line, we have used the concatenation assignment operator. And I know it looks just like the addition assignment operator we talked about in the last lesson. But in this case, it does the same kind of idea. We're going to take the existing value of message and we're going to tack onto the end of it a new string, the child lives in the USA. And that whole string, the child is 5 years old and the child lives in the USA, that whole string will now be stored in the variable message. So let's go recreate this very same or something very similar set of code in our Codio file before we move on to the next topic of Booleans. So if you have the lesson 3 demo open, you can open index.html, and I've got a little bit more in here this time for you. We'll learn about some of these things a little bit more down the road. You've already seen some of them. We have imported the jQuery library from the Google hosted libraries. And we have another script tag where we have the document ready event function that simply says, wait until the whole document's loaded before you execute this stuff. So we're safe now to put in here variable name, and why don't you put your name inside the quotes. All right, now we're going to console.log. All right, let's type out the whole message first. Hello, Phil. Welcome home. All right, so that's what we want, except you don't have Phil here. You are going to put your own variable here so that your own name comes out here. And really, whatever is assigned to that variable should go in there. So instead of Phil, we're going to close the first quote, concatenate name, concatenate the second string. So you follow? First string, variable containing a string, third string. All right, so let's go check the results in the browser, where we should see, hello, Phil, welcome home. So the beauty of this is that regardless of what's stored in the name variable, that's my wife's name, we see the concatenated result. So in reality, what we might actually do is that the value that's stored in name might not actually be something we've hard-coded. We might have this being read from an input field that the user has entered themselves as a part of some form that they're filling out. And we're going to grab that value right out of the input. It's going to come in as a string, and then we're going to concatenate it into a little message out to the user. Let's continue. Let's try the age option, age 33. And this time we're going to declare the variable message, and we're going to assign to it the adult this time is age, years old. Okay, now notice how I've been careful to make use of spaces. If I forget those spaces, watch what happens when I preview this. Actually, I'm going to leave that console log right on the next line down. Okay, so we're just logging the value stored in message right now. And you see it's the adult is 33 years old and it's all stuck together. Well, that's not very pretty. We fix it simply by making sure that we have an actual space character as a part of the string on either side of this variable. And the result's a little prettier. Okay, so underneath this, I'm going to use that concatenation assignment operator to add a new string onto here. And you'll see something else here. So the adult lives in the USA. All right. So notice that I'm going to leave this first console. And now I'm console logging that same variable again, but we have changed that variable on line 20. So now the first line that we see in the console, outputting the variable message, should contain just this little phrase. But the second time we see it, we should see this phrase and this phrase. See? And we forgot to put a space in there, which we could do either at the end here or knowing that we left it off there, we could put it here. Either way, we get the space there that we're looking for. All right, hopefully you get the idea. We're going to get lots of practice with working with strings and lots of practice working with concatenation in our exercises. But carrying on, the next thing we have to talk about is Booleans. And we have some new syntax to learn. We have some new keywords to learn. And Booleans are a data type. And along with them, we have a package or a set of operators that we'll use. So Booleans are a literal data type, like numbers and strings, that can be one of two values, true or false. So what does that mean? Well, it gets rather philosophical, but ultimately it comes down to your kind of classic idea of 0 or 1, on or off. True is just a catch-all way of saying yes or good, and false is sort of a catch-all way of saying not true or bad, just depending on what you're doing. So we'll see how this works. And like with the other data types, we can set these with the keywords, set variables to contain these with the keywords true or false. As you can see on the next two lines, the variable need groceries is assigned the value true. So we're simply saying that it's true that we need groceries. Yep, we need groceries. Or the cart has contents is assigned the value false. Cart has no contents, but maybe once someone has added something into their cart, we come back later and we change that variable to be true. So the true power of Booleans is going to become a lot more apparent in a few more lessons from now when we talk about conditional statements and other things like that. But Booleans are essentially a base for a ton of processing power thanks to comparison and logical operators and other structures that we'll learn about later. So we do intend to cover the comparison and logical operators right now. First up, the comparison operators. You should be pretty familiar with the first four of these. Less than or equal to, greater than or equal to. And now we introduce two new ones that actually deal with equality. So the double equal sign is actually read as equal to. And the exclamation point equal sign is not equal to. So the idea is, like we can see on the first sample code there, the variable eligible for free shipping is assigned the result of the comparison here. So cart total is greater than or equal to 30. So essentially, we don't know what cart total is, but let's say that it's 20. So cart total would now contain the value 20, and so we would be comparing 20 greater than or equal to 30. Well, is 20 greater than or equal to 30? No, it's not. So that would resolve to false. So false is the value that would be assigned to eligible for free shipping. JavaScript reduces the expression on the right-hand side down to the Boolean value that is a result. So if cart total contained the value 45, then we would have 45 is greater than or equal to 30. Is that true or false? Well, that's true, right? 45 is greater than or equal to 30. So true is what would be stored in eligible for free shipping. Okay, hopefully you get the idea. Same idea on the next line. Son is older. It's a really funny one, right? Is the son's age going to be greater than the father's age? Boy, that would be pretty strange if that was the case. So very likely that is going to reduce to false. Now here's a common situation. A username matches is assigned the result of the comparison between username provided and saved username. Perhaps saved username is the username we looked up in a database, and username provided is a value that we retrieved from a form field or something like that. Well, we would simply be comparing them, and if they are equal to each other, if they are the same, then that would reduce to true. And if they're not the same, then it would reduce to false. So let's test out at least one of these. Let's test out the first one here. Eligible for free shipping is assigned the result of the comparison cart total is greater than or equal to 30. So if we move over to Codio and we put this in, All right. What we're going to try to do is console log the result. Okay, but we have an important thing missing, right? We have not defined cart total, so if we tried to do this, we'd probably get an interesting result. So let's declare cart total and rig it. Let's set it to something intentional. Let's say 25. So it would be 25 greater than or equal to 30. Well, that's false, correct? Right? So false is what we should see in the console. And it is. Now, if we make it 30 on the nose, 30 is greater than or equal to 30, right? So we should see true. And there you have it. Okay, so that's how comparison operators work. I think those are some of the simpler ones. Let's just test the not equal to idea. So 30 is the same thing as 30. So is 30 not equal to 30? That feels like strange logic, right? Well, they are the same. So it is false that they are not equal. So we should see false. Whoa, boy, if your head's spinning, I don't blame you. More likely, if we say, is it 35 not equal to 30? Well, they are not the same. So it is true that they are not the same. Cool. All right, let's move on to the logical operators. Logical operators are going to feel a little bit more abstract for now, but essentially we're going to be working with situations where there will be a truthy statement on one side and a truthy statement on the other side, or a falsy statement on one side or the other. And we're testing to see if either or both sides are true or not. So let's follow the logic here. First, the variable is a member is assigned the value false. Then the variable eligible is assigned the value resulting from the comparison between cart total and 30. So if cart total is greater than 30, we will have a true stored in eligible. Okay, so let's just imagine that eligible is resulting in true for now. So is a member is false and eligible is true. So in the third line, we are saying the variable show discount is assigned the result of this logical operation. So the OR operator allows us to test whether at least one of the sides here is true. If either side is true, then the result of the comparison is going to be true. So in this case, is one of those two values true? Yeah, we said a moment ago that eligible is true. So while the first one is false, the second one, eligible, is true. So the overall result of the OR comparison, a comparison of either or, is true. One of them is true. All right, let's think about the next one. Son is older is assigned the logical operation, has a son, and now we have a compound statement here where we are comparing age is less than son's age. So this is never going to be true, right? Logically thinking. But the AND operator expects both sides to be true. So if both sides are true, then this will resolve to true. But if either side is false, then it breaks and this resolves to false. So both sides must be true in an AND operation, but only one side needs to be true in an OR operation. In the XOR, frankly, I've never used XOR in programming for the record, but there are cases where it would be needed. XOR tests to make sure that only one side is true. So if both sides are true, then XOR is going to result in false. But if only one side is true, then XOR would result in true. Now, if both sides are false, well, obviously, neither side is true, so that would not be true either. And the last one there is the exclamation point or the not operator. Sometimes you'll hear this called bang. So, for example, at the very, very bottom here, it says the variable show page 2 is assigned bang show page 1, or not show page 1. So it's basically going to just invert whatever value is to the right of it. So true is assigned to show page 1. So show page 2 is assigned not true. What's not true? False. So false is assigned to show page 2. Boy, I know these are strange, but never fear. We will get to see these in context a little bit later when we deal with the conditional statements. I wanted to cover them now as they make more sense in terms of understanding what true and false are, and you can maybe begin to see a little bit of the power that they unlock. So let's move on to the next topic though, and that is functions. With functions, we have to learn how to declare functions and how to call them. And so we're going to learn some new syntax and a new keyword that relates to that. So what in the world are functions? Well, they're grouped sets of code, often code that we want to be able to reuse. So think of something that you have done many times in your life. Perhaps you learned at one time how to calculate the area of a rectangle. That's accomplished how? Do you remember? Let's see, it's the product of width and height, right? Width times height equals area for rectangles. Okay, so that's great. If we really wanted to be able to do that quickly, we could create a function that allows us to pass in a width and a height, and what we will get out of the function is the area. That seems very simple, so maybe a more complex one would be not just to calculate the area, but to actually also output a little message to the console that says the area you have calculated is, and then it shows the area. That kind of something would be useful, and boy, there are tons of things that functions become useful for, but they basically make us more efficient. So along the way here I mentioned what the second bullet points out, and that is that values can be passed into functions as parameters. So we're going to be putting in values, and then we're also going to often return a value out of the function. Think of a vending machine. You are going to input change and select the candy, and the vending machine is going to do its thing, and assuming it's not old and broken, bada bing, bada bang, down at the bottom of the vending machine, out pops the candy that you selected, right? Okay, that's the same idea with a function. You're going to put in some values, it's going to churn behind the scenes, and you're going to get something useful out of it. So parameters are the inputs, the return is the output. Now, many already exist, many functions already exist as a part of JavaScript itself. And even more come with the jQuery library that we'll be learning about. So these are things that are going to encapsulate a whole bunch of useful sets of code that we can call and do things. And so just knowing how to call existing functions is huge. But we can also define our own functions and then later call them to make use of them. So let's take a look at that. We declare functions using this syntax. The keyword function followed by the name for the function. Anonymous functions allow us to omit this, and we'll talk more about anonymous functions in a minute. Then we have a parenthesis pair, and inside the parenthesis we pass in a comma-separated list of parameters that this expects. So again, that's the inputs, right? So this is just basically variables that we can then use as we declare the function in step 3 here. That's the code that goes between the curly braces. We can use any of those parameters inside to do whatever calculations or computations we want. And we also usually end number 3 with a return statement when we want to send some value out. So, you know, talking about this is kind of abstract, right? But make sure you've got the placeholders noted here, and we'll move on to look at some examples. So first we have an example of what I talked about early on in this section on functions, and that's, you know, finding an area. So we've declared the function find area, and we've indicated that it allows a width and a height value to be passed in. So what we're doing is returning the product of width and height. So if we pass in a 5 and we pass in a 10, 5 comma 10, when we call this later, it's going to take 5 times 10 and return the value, 50. So 50 is what would come out of this function. The second example, the function add tax, accepts one parameter called current total. And inside of this, we declare a new variable called tax that's set to 0.065, which is a way of saying 6.5%, right? Then we say the current total is, we use the addition assignment operator. So we're going to add to the current total times the tax. And then we're going to return that new value. So we're taking the current total, we're adding to it the tax value of the total, and we're outputting it. And then last of all, prepare greeting is going to accept a username. We're going to declare the variable greeting and assign to it hello, comma, space. And then we're going to concatenate onto that username and concatenate onto that, period, welcome to the system. So here you see kind of broken out into multiple lines, something that we did earlier where we did it all on one line with just concatenation operators. And then we're going to return greeting. So I'd encourage you to flip on over to Codio and try to put these functions in for yourself and see actually I'll go ahead and do one so that we can practice with it. Let's do the add tax one. So adding tax, basically I'm going to wipe all of this out. And I'm actually going to go above my DRE here to declare my function, just to kind of set it apart. So add tax. It's going to take in a current total. All right, so now you may remember that curly braces identify a code block. So it's essentially saying this code set belongs to this function name add tax. So we're going to say current, we're gotta do tax first, right? Var tax is assigned 0.065 for 6.5%. So then we're going to say current total. Now we did not use the var keyword here because current total is already existing. It's a parameter that's coming in, so we don't have to declare it. But we're going to add to it and assign to it at the same time the result of current total times tax. And then we're going to return current total. All right, so with that saved, if I go over here and refresh, you see that the console clears out because I removed some of that stuff that we had there before. But we're not seeing anything. Well, that's because we haven't actually called this function. We haven't ever done anything with it. All we've done is set it up so that it can be used if we'd like to use it. So let's look at that next. How do we actually call an existing function? Well, it's simple. We simply enter the name of the function followed by parentheses. And if there are any parameters that it expects, we pass them in between those parentheses. So down below you can see how we would call the find area function. Now what we've also done is assigned the result of that function to a variable called area. And this is something that is also very common with functions. It's normal that if we're going to return a value, we're going to want to store that value in a variable that we can work with later. Otherwise, we might just call the function inside of a console log so that we're outputting the result of that function. But anyhow, the assigning it to a variable is a pretty common thing. So let's go take a peek at how that works. So over in here, we would call current total, right? And current total expects, I'm sorry, add tax is the name of the function. Add tax expects a value represented by current total. So let's imagine that our cart's total is $5.99. So $5.99 is what's going to be passed in for the current total. And we're therefore going to add tax to current total and return the new total. But so notice if I call that function and I go refresh in the browser, well, I'm not seeing anything, right? Because I haven't actually told JavaScript to show it in any way. So I could, console log, and make sure I have the matching parenthesis for that console log after the parenthesis that closes the function parameter set here. All right, so now I should see the taxed value. All right, or I could assign this to a variable. New total is assigned the result of the function add tax with the value 599 passed in for the parameter. So now I could console log new total, and I accomplish the same purpose. So you can see there are times where we might output something straight to the console by putting that function straight in here. Much more common than what we're going to do is assign the result of a function to a variable and then output that variable or do something else with that variable. All right, what's next? Oh yeah, we showed a couple examples of calling functions here. So you can see we've called find area with two different sets of values, 4 and 8, and 23 and 42. And we've called the add tax function down below with the value 124.78 passed in. And we've called the prepare greeting function passing in the username Phil. So feel free to step back and test out each one of those functions if you'd like. Now, a moment ago I mentioned that some functions are anonymous. What's the deal with that? Well, remember that the whole idea of a function is having some reusable code. That's kind of the main thing. And so when we want to have code that we reuse, it's likely that we want to associate a name with it so that we can call it and reuse it. But there are other cases where we actually want to use a function to really process a set of code one time. An easy way to package that set of code is to do so by way of an anonymous function. So we simply omit the function name and just use the function keyword followed by parentheses and any parameters that we're passing in, followed by a curly brace. And we'll talk a lot more about why these are useful down the road. But the common example you've seen to date is what we use in our DRE. I've got a minified form of the DRE in the Codio file that we're working with here, but the same idea is in place. This is an anonymous function that opens here and closes here, and the lines we've been entering all along have been a part of that function. The idea, though, is that this function is kind of immediately invoked function. It's called right away when the page finishes loading, whereas this function is defined, and we don't actually call it until several lines down when we actually want to do something with it. So more about anonymous functions will come, oh, I failed to call out the text here. So I kind of jumped right down to the DRE and talked a little bit about how in some situations we want functions to really just be kind of used on the fly. But the most common instance for this is when we're dealing with functions that allow other functions to be passed as parameters, such as event listeners. We'll be working with Ajax, which will take some time to be processed, and we want to have a function that's called when that processing is finished. And so we'll have anonymous functions that can be just one time used for those purposes. Okay, a lot of new stuff there, but opportunities to practice with each one of those on the exercises. And don't worry, there will be lots of time to be exposed to functions before you'll actually have to do anything completely original on a project. In fact, it'll probably actually be project 2 before you'll have to write any of your own functions. We'll be using provided functions in project 1. So enjoy the exercises and reach out if you need any help.